Let me show you the first wall everyone hits when they try to build something real with AI. You make something small and genuinely useful. You ask the AI for a customer's renewal date. Your code takes that date and schedules a reminder email. You test it, it returns 2026-09. Your code reads it, the reminder fires. Perfect. You ship it. 3 weeks later, a customer's renewal quietly passes and no email ever goes out. You dig into the logs and there's the culprit. This time, asked in the exact same way, the AI didn't answer 2026-09. It answered, "The renewal date is September 2026. Let me know if you'd like me to set up a reminder." Your code was waiting for a date. It got a friendly sentence. It choked. And here's the maddening part. You changed nothing. Same code, same question. The AI just decided to be chatty that day. If you want to build with AI, you have to beat this one problem. You cannot trust the shape of what comes back. So today we fix it, and by the end, you'll be able to force the model to answer in exactly the shape you need every single time. To fix it, you have to understand why it happens, and it goes right back to what this thing actually is. From last season, an AI model is a next-word predictor. It builds its answer one piece at a time, one token, and at every single step, it looks at everything so far and picks the most likely next token from its entire vocabulary. Every word it knows, every punctuation mark, every emoji, all of it on the table, every step. So when you ask in plain English, what is the most likely way to begin an answer? Very often, something polite and human, sure. Here is the renewal date is. The model isn't ignoring you. It simply has no idea that somewhere there's code waiting for a bare date. You asked in human language, so it answered the way a human would. Plain language hands the model total freedom over the shape of its answer, and total freedom is the enemy of anything you want to build on. So the whole game, the thing this entire episode is about, is this. How do we take that freedom away? The first thing everyone tries, and you should, is to simply ask more clearly. This is prompting done well, and 2 moves matter most. The first, give the model a role. Instead of a bare question, you open with a standing instruction. You are a data extraction service. You output only raw values, never sentences. That opening instruction is called the system prompt. Rules set once and applied to every turn, like a job description, the model wears for the whole conversation. The second move, be ruthlessly specific. Not give me the date, but output only the renewal date as year-month, no words, no punctuation, no explanation. Why does this help at all? Remember, the model is weighing odds at every step. A firm role and a precise instruction shift those odds. They push sure down the list and a bare date up it. And it genuinely works most of the time. But sit with that phrase, most of the time. You have not removed sure from the realm of possibility. You've only made it less probable. You nudged the dice. You didn't take them off the table. On the 1000th call with one odd input, the unlikely thing happens anyway, and you're back to a 2 a.m. crash. Asking more clearly is better. It is not yet a guarantee. So you reach for a stronger tool. Show, don't tell. Instead of describing the shape you want, you give the model a few worked examples right there in the prompt. Here's an input and here's exactly the output I want. Here's another, and another. Then you hand it the real one. This is called few-shot prompting, and it's surprisingly powerful because the model is a world-class pattern matcher. That is literally the thing it does. Show it 3 inputs that each map to a clean, bare date, and the pattern it now predicts as most likely is a clean, bare date. You've stacked the odds steeply in your favor, but notice what we keep bumping into. We are still in the world of odds. Few-shot makes the right shape far more likely. It still does not make the wrong shape impossible. For plenty of real work, far more likely is genuinely good enough. But if your code truly cannot tolerate a surprise, if a single malformed answer means a missed payment or a broken page, then you have to stop playing with probabilities altogether and reach for something that gives you a hard guarantee. Here it is, the move that turns hoping into certainty. Everything we've tried so far, roles, instructions, examples, works by nudging the model's choices. This works by removing them. Picture the exact instant the model is about to write its next token. Normally, it has its whole vocabulary to choose from, ranked by probability. Structured output puts a gate in front of that choice. You hand the model the shape you want, usually JSON, a simple template of named fields, and at every step, the gate looks at what would keep that shape valid and crosses out everything else before the model is allowed to pick. Watch it happen. Step 1. A valid JSON answer can only begin one way, with an opening brace. So the gate takes the model's ranked options, sure, a brace, a quote, and forces the probability of everything that isn't a brace down to 0. The model wanted to say sure. That option no longer exists. The only door left open is the brace, so it walks through it. Step 2. Right after that opening brace, because you asked for those exact fields, the only real option left is your first field's name in quotes, so once again, every other token is zeroed out. Step 3, Step 4, the same story. At each point, the shape itself decides which tokens are even allowed to exist. The model is still predicting the next token, but now it's choosing from a list we have pruned down to only the valid ones. It is not obeying you. Every token it's even allowed to pick keeps the JSON valid, so it literally cannot wander back into a chatty sentence. The main way you'd still get broken JSON is if the answer runs into a length limit and gets cut off partway, so you give it room to finish. The other, rarer case is the model refusing on safety grounds, which can override the shape. This feature has a name you'll meet in every provider's docs: structured outputs, the stronger successor to the older JSON mode, which only promised valid JSON, not your exact shape. You'll also hear the underlying trick called constrained decoding. You stopped asking nicely. You made the wrong shape impossible. Let's watch the whole ladder for real, running free on your own computer. Same local model as episode 1. First, plain, extract this customer. It comes back as a chatty paragraph full of markdown bullets, nice to read, useless for code to parse. Now I add a role and a clear instruction. Tighter, it drops the chatter and hands back just the raw values. But look closely. It picked its own shape, the values strung together with commas, not the structure my code is waiting for. Now I add a couple of worked examples and it finally gives me clean JSON usually. And now the guarantee. I pass a format, a schema naming the exact fields I want, and I run it again and again and again. Every single time, the same clean JSON, exactly those fields, nothing extra. Not usually, every time. That is the difference between a demo you hope works and something you can actually build on. One last thing, and it may be the most important sentence in this episode. Structured output guarantees the shape. It does not guarantee the truth. The model can hand you flawless, perfectly formed JSON with the wrong renewal date sitting right inside it. The container is perfect. The contents can still be wrong. Locking the shape solves will my code break. It does nothing for is the answer actually correct. And that second question, how do you know the contents are right, turns out to be the very skill that separates people who build impressive AI demos from people who build AI you can actually trust. So here's the ladder of control from softest to hardest. Ask clearly, give the model a role and precise instructions. Show it examples so it matches the pattern you want. And when you need a hard guarantee, use structured output to make the wrong shape impossible. Together, that's how you get an answer your code can rely on every time. But notice something. Through all of this, the model has been answering only from what was baked into it during training. It doesn't know your documents, your notes, your world. Next episode, we change that. We hand the model your own knowledge and teach it to answer from your sources and even cite them. That's RAG. See you there.